It's likely that every one of you knows someone that suffers from heart disease and has had to grapple with that terrible news. The damage done is irreversible. Or is it? My name is Preston Stafford, and I studied the signaling of the immune cells to the heart during maturation to find cures for heart disease. Now, in a broad sense, in the adult, heart disease causes damage, which leads to the death of muscle cells that keep your heart beating. Those muscle cells are then replaced with proteins that create a scar, keeps your heart from bursting, but leads to less efficient pumping, which is bad for patient outcome. Now, many of you might be thinking, why is an organ as important as the heart unable to replace its cells? Well, what if I told you it might be able to? Every one of us, when we are first born, may have the potential to have damage to the heart that is completely regenerative without the formation of a scar. And this is able to happen because of one important reason. Immature heart muscle cells are still able to undergo cell division. They're able to make more of themselves, whereas the adult muscle cell is not able to do that. And this is where the immune cell comes into play. So I study a very unique and rare type of macrophage called the tissue-resident macrophage. Now, many of you have seen today and may have heard before that the immune cells are typically seen as the crime fighters, the ones that go after bacteria and viruses, but they do so much more. They're able to be firefighters to dampen inflammation, trash collectors to clear out debris, physicians and nurses to keep the cells around them alive and healthy. I study how the macrophage operates like a primary school teacher, helping guide immature muscle cells into their adult stages to take on the burdens of adult life. Now, importantly with this, if you've ever gone into a school and you don't know any of the staff, knowing who is a primary school teacher and who isn't is very difficult. And that same difficulty translates into studying these guys. And I use 2 mouse models in order to overcome this. The first is a genetic reporter line, which is like putting a big spotlight on only the primary school teachers. And with that spotlight, I also have an ablation model, where I can remove those primary school teachers from the classroom and see what happens to the muscle cells as they grow up. And in this, hopefully, we'll be able to determine what messages these macrophages are sending to these immature muscle cells to help them become mature and unlock some novel pathways that we can target to help heart patients. And in this discovery is something profound. What was once thought to be irreversible and impossible, healing a broken heart, may one day become a reality. Thank you.